Topic 3 is exponent rules. This topic is going to have two objectives. The first objective is going to be master these rules, or master the properties of exponents. Alright, this is review from Algebra 1, but I still want to go over it because you're going to use these properties and the mastery of these properties in Objective 2 when you use the exponent rules to simplify rational exponents and radical expressions. And if you can see, it does look a little bit complicated, so it's good to master these to begin with to make the process a lot easier for Objective 2. So to begin Objective 1, I just want to reiterate the two terms or vocabulary you're going to hear in this, a base and an exponent. So they've given you the example 5 squared. 5 is considered the base because it's the lower component, and then the exponent is the higher component, or the power of 2. So another example, x cubed, x would be the base, and the power of 3 would be the exponent, all right? So you'll hear me say things like base times base, you do something to the powers, or base divided by base, or base raised to the, something like that. And so that's just the terminology that I'm working with, all right? So a couple examples of the first, and we're going to get into the actual rules or properties of exponents now. And I'm going to do examples along the way, and then I'm going to have you pause the video and try some examples on your own, just to make sure you're tracking with the information and you're mastering it along the way as well. So the first property that I care about is called the product property. So base times base, you add the powers, all right, or add the exponents. A couple things to keep in mind. The bases have to be the same, all right? You have to multiply the same bases in order to do, and that goes for any one of these rules. They have to be the same bases in order to apply these rules, all right? So here's an example. A to the m times a to the n equals a to the m plus n. So you add the powers, all right? I'm going to do the examples on the left. I'll have you do the examples on the right. The first thing I look at when I see 5 squared times 5 to the 6th is that the bases are indeed the same. So I can apply the product property. I'm going to rewrite this. 5 squared times 5 to the 6th. Now, base times base, base times base, you add the powers. All right, so this is going to become 5 to the 2 plus 6. And then finally, 5 to the 8th. All right, because it was the same base, I could add the powers. Now, because this is a number 5, I could actually evaluate this and tell you what 5 to the 8th is. But for the sake of just practicing the properties of exponents, I'm just going to leave that as is. So my final answer is 5 to the 8th. I've added the powers, all right, because they were multiplying the bases. Now, base times base again for the second example, but this one's a little bit different because it has coefficients with it, all right, that don't have powers, that they have powers of 1. But when you see coefficients, like I see 7 and I see 6, you just treat them as normal numbers, all right? You just multiply them. So 7 times 6 is 42. And I'm going to deal with the numbers first. 7 times 6 is 42. Then I look at the bases of y to the 5th and y to the 1. Even though it's not written, I know that it's y to the 1. Now I do y to the 5 plus 1 because it's base of y times base of y. Base times base, you add their powers. So this becomes 42 y to the 6th. I multiplied the numbers, 7 times 6 to get 42, and then I multiplied the y's together and added their exponents, so I get y to the 6th, and that is my final answer. So go ahead and try the next two examples on your own. Keep in mind that you have to check first, are they the same base? If so, then I can multiply the bases and add their powers. And again, if there's just numbers, like in this example, there's a -3 and a 5, I just multiply those, or do whatever operation it's asking me to do. I'm multiplying. All right, and so keep in mind you have to keep the bases the same, and this x is raised to the power of 1 when it's not written. So go ahead and try this, and then check your answers with mine. So please pause the video this time and try these two examples. You should have paused the video and tried these two on the right on your own. And so I've showed you out the steps that I've taken to arrive at the answers that I've gotten. So if you would like, this would be a really good thing to do. Please get in the habit of showing it step by step your thought process, just so you can practice this and make sure you know what is happening in each step. The first one, I have all the same bases. They're y's, so I can apply the product property. Base times base, you add the powers. That's what I'm showing in step 1. So it becomes y to the 4 plus 3 plus 1. I'm adding its powers. And so finally, I get y to the 8th when I do that math of 4 plus 3 plus 1. And I'm done. So I only have one y now, and I've added all of its powers to tell me how many y's were left over. Down here, it's a little bit more work because if you notice, I have coefficients out front. So I did that math first. Negative 3 times 5 is a negative 15. That happens in my first step. Now I'm showing here I have a base of x times a base of x. I add the powers of 2 plus 1. So now I have x to the 2 plus 1. And then a base of y times a base of y. Base times base. You add the powers. So I get y to the 7 plus 6. And my final answer then is negative 15. X to the 3rd, y to the 13th after I do that math. And I'm done. So again, please raise your hand if you didn't get this so that I can come check your work. Let's move on to the next property or rule. And it's the quotient property or the division property. So again, this states that base divided by base, you subtract the powers or exponents. Again, it has to be the same base. And if you notice up here, it's an example, a to the m divided by a to the n equals a to the m minus n. So base divided by base, you subtract the powers. All right. So I'm going to do 2 examples, and then I'll have you do the third on your own, the most challenging one, to challenge yourself and see if you can get this. The first example, again, the first thing I think, are they the same bases? And in this case, they are. So my first step is I'm going to show the work that I'm doing. The base of y to the 6 divided by the base of y to the 1. So now this becomes y to the 6 minus 1. And then my final answer, because it's the same base, I apply this to the division property, which you subtract the powers, becomes y to the 5th. And I'm done. Same thing with the numbers here. First thing I think about is it the same base? Base divided by base, I subtract the powers. So my first step, yes, it is the same base. It's the base of 6, and I'm going to rewrite the powers as a subtraction problem. 13 minus 2. So my final answer, again, is 6 raised to the 11th. I could evaluate that because it is a number, but I'm going to leave it as 6 raised to the 11th. So please try this next one on your own. Again, I didn't talk about what happens with the 10 and the 15, but they're both coefficients, and so the same thing, coefficients up here, I multiplied them. Negative 3 times 5, because it was multiplication, became negative 15. So in this case, you just do 10 divided by 15. It's going to give you a fraction. Hit math, enter, enter on your calculator to give me the simplified fraction. And then work the product property. The quotient property. So when you do base divided by base with your variables, you subtract their powers and see if you can approach something to what I get after you pause it. So please pause the video and try this one on your own. So at this point, you should have paused the video and tried this. Again, this is a little bit of a challenging problem because we haven't talked about some other properties that come into play, but I wanted you to discover this on your own a little bit. So I'm going to do the first step of 10 divided by 15. And all that is a fraction, 10 over 15. So all this process is that you want to simplify that fraction. Hopefully you can do that in your head, but if you can't, on your calculator you just hit 10 divided by 15 and hit enter. It's going to give you a decimal, so you go to math and hit enter twice, or I want the fraction option, turn it into a, so it's already on that, so I hit enter, and then it's going to say, do you want to answer as a fraction? Yes, so I hit enter again. So that fraction is 2/3. So my first step is to write that as its simplified form. 2 over 3, all right? And then I'm going to extend my fraction bar. Now I'm going to apply the quotient property or the division property. Base divided by base, you subtract the powers. This happens in the numerator, all right? So I'm going to show this step in the numerator. I have a to the 7 minus 5. Alright, and then b to the 9 minus 9. I'm just showing my work. Alright, so hopefully you showed your work something like this. Then my final step, I still have 2 thirds. A to the 7 minus 5. 7 minus 5 is 2, so I have a squared. And then finally, b, 9 minus 9 is 0. We're going to talk about this rule in just a second, but anything raised to 0, you can try it on your calculator. Punch in like 5 to the 0. It is 1. Alright, so b to the 0 becomes 1, so I don't have to write 1, so my final answer is 2 thirds a squared. So 2a squared over 3 is my final answer. Please raise your hand if you need to talk through that with me, that process a little bit. But hopefully your answer looks something like at least step 2. Alright? Let's move on to the next power. Or the next property, I'm sorry. The next rule is what we just talked about, the 0 exponent. So any non-zero number with an exponent of 0 is equivalent to 1. Alright? And so I'm going to bypass this and just jump down to this example. Anything raised to 0 is 1. So if it's in parentheses or if it's by itself, anything raised to 0 is 1. So the step I'm going to take when I see that is immediately cross out all that it is that's raised to 1, and in this case the entirety of negative 3x plus 7 raised to 0 is 1, and I'm going to write 1. But when I'm doing these problems later on, I don't need to write 1, I'm just going to cross it out and consider that it is 1. So go ahead and see if you can do this next one on your own, alright? Keep in mind, the 8 is not raised to the power of 0, only the x is raised to the power of 0. So I wouldn't cross out the 8, I would only cross out the x. So pause the video, try to see if you can get to the answer. At this point you should have paused the video, and I'm going to show you the steps I would take. Instantly, if I see a variable or a number raised to 0, I'm going to cross it out and consider it to be 1. 1 times anything is itself, so I don't have to put 1, I just know that it now becomes 1. So I'm left with 8 plus 5. And again, you might ask, why didn't I cross out the 8? Because if I write that term out again, 8x to the 0, only the x is the base with the power of 0. So the power of 0 is only paired with the base of x because it's above the x, not the 8. So I don't cross out the 8. So in my first step, I'm left with 8 plus 5, and my second step finally is 13. So I've simplified that as much as I can. End this first video here, and I'm going to make a new video to talk through the final 2 exponent rules or properties, the negative exponent rule, or when an exponent or base is raised to a negative power, and then power of a power. Alright, so at this point this video is going to end, and I'm going to continue the final 2 properties in the next video.